In this video, we will cover scientific notation. Let's say that we are astronomers, and we want to write out the distance from the Earth to the Sun in meters. The Earth is 150 million kilometers from the Sun. Let's write this number out in decimal notation just so we have a reference. Because a kilometer is 1,000 meters, 150 million kilometers is 150 billion meters. If we had to write out 150 billion this way over and over again, we would get tired and use lots of paper. Instead, we can write 150 billion meters as 1.5 times 10 to the 11th meters. Where did the number 1.5 times 10 to the 11th come from? Well, notice that 10 to any power is just a 1 followed by that many zeros. For example, 10 to the third is a 1 followed by 3 zeros, or 1,000. If we took 2 times 10 to the third, we get 2,000. Or 2.5 times 10 to the third is 2,500, or 2,500. Scientific notation is a way of expressing any number as a product of two things. First, a number between 1 and 10 written in decimal notation, and second, 10 raised to some power. You should pause the video now and fill in the box above section 3 on your worksheet. Let's look at some examples. Our first example is 17 times 10 to the 8th. However, this is not in scientific notation because 17 is not a number between 1 and 10. So 17 times 10 to the 8th is not in scientific notation. Our next example is 2.778 times 5 to the 4th. Again, this is not written in scientific notation because the base of our exponent is not 10. Finally, let's look at 3.33 times 10 to the minus 12th. This is written in scientific notation, despite the fact that the exponent is negative. We will get to this later. For now, let's go back to the problem of writing 150 billion meters in scientific notation. The first step is to get a number between 1 and 10 that we can multiply by some power of 10. We look at the part of our number that has non-zero digits, here, and write it as a number between 1 and 10. 15 equals 1.5 times 10 to the first. So 1.5 will be the decimal part of our product. We still need to figure out what power of 10 to multiply 1.5 by, though. To do this, we start at where the decimal place is in our original number. This is the decimal place. And count how many times we would have to move it to the left before it lies between 1 and 5. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Thus, we multiply by 10 to the 11th, and this is our answer, written in scientific notation. Let's see one more example. This time we will use scientific notation to write a very small number. This is a dust mite. Most dust mites are about 420 millionths of a meter long. In decimal notation, 420 millionths of a meter looks like this. To put this number into scientific notation, we will do much the same thing as we did in the previous example. Start by finding the part of the number that we will have to write in decimal form, In this case, that is 42. We can write 42 as 4.2 times 10 to the first. So 4.2 is the decimal component of 420 millionths written in scientific notation. Again, we can get the exponent part by moving the decimal until it agrees with 4.2. This time we have to move it 1, 2, 3, 4 places to the right. Thus, -4 is our exponent. So we can write 420 millionths of a meter as 4.2 times 10 to the -4th power meters. This concludes the video for scientific notation. In the last video, we worked through the starred problems on section 3 of your worksheet. Thanks for